Good morning, everyone. We've used the term green to describe a series of technology and industry trends that we believe will be driving green building development and operations over the next decade. The green building movement in the United States is entering its third decade. And we believe that the green building industry has reached a tipping point and will bring in many new technologies and capabilities to building owners and operators. There are 5 key elements of the future of green buildings. One is buildings will be more grid responsive. They will communicate to the grid and from the grid and respond to the demands of the electric utilities and energy service providers. They will be more resilient. They will be more secure, and they will be better adapt to severe weather and other changes in their environment. They'll of course be more efficient in the use of energy and other resources. They'll be energy positive. The trends towards renewable energy will make buildings not just a user of energy, but a source of energy to themselves, their communities, and the grid as a whole. And finally, they will be more networked. They will leverage information and communication technologies to provide greater capabilities. The green building movement, in fact, has reached a tipping point over the last 2 decades. In a survey which we've done every year for the last 7 years with 3,000 facility managers and energy managers at organizations in 10 countries around the world, we found that the importance of energy management has never been greater. 41% saying that energy management is very, very critical and very important to their organizations. And a very important statistic is, does your organization intend to achieve a voluntary green building certification for any of the facilities? Among the 3,000 building owners prior to 2012, only 5% had certified a building to a green rating system or a standard. In 2013 alone, 29% do. Indeed, a tipping point. So let's talk about the future of green buildings. The G in green buildings stands for grid responsive. And most people have heard of demand response. Over the last 5 or 10 years, demand response has meant that in response to a critical shortage of electricity or other emergency within the grid, a signal is provided to a building owner, and that building owner would take action, either turning off non-critical loads or turning on backup generation to avoid energy demand. That relieved the requirements on the grid and provide a valuable service. But that's really just the beginning of demand response. Another form is more significant, where instead of for a couple hours a year, buildings actually adjust their operation over the course of a day, taking advantage of higher priced electricity during the day and lower priced electricity during the night to be able to provide energy storage, pre-cool the building, take a number of actions which allow the overall demand on the grid to be reduced. We call those the energy markets, and here in the East Coast, PJM, the grid operator, has very sophisticated programs which building owners can opt into to deliver those services and be compensated. In the future, we expect buildings to be active elements, megawatt power plants, providing services to the grid at large, either by providing spinning reserves where buildings could respond in a period of 10 minutes, reducing energy demand or providing local generation, or up to including regulation where responding to a 1 to 4 second signal, being able to alternatively store and discharge energy from batteries. This is a great application for electric storage batteries, an emerging technology, and it turns every building into essentially a small little power plant serving the grid in aggregate. This is Georgia Tech. They were an early pioneer in grid response. For many, many years, they've actually received hourly pricing information from their utility, Georgia Power. It's a 24-hour forecast of the energy price. The building automation system at Georgia Tech takes that information and adjusts set points across the campus in order to reduce energy and demand. Through the use of this automated system, they've been able to reduce the demand on their campus by 7%. So they would typically do this in classrooms. Yes, dormitories, but certainly not research laboratories or animal facilities and things like that. Early pioneer in the area of grid response. 15% of all organizations in the US in our survey have actually implemented some form of demand response. The R in green stands for resilience, and I think we all became more aware of the importance of resilience after Superstorm Sandy, where many building owners and homeowners in New Jersey and New York who had solar installations on their homes were shocked and surprised when it was sunny outside and they didn't have any power in their homes. The problem is that to protect the grid and workers that would be bringing the power back to the electrical grid, those systems automatically turned off. If the systems had been designed differently and they had a transfer switch, they could have taken advantage of that solar energy to provide critical services within their buildings and powers. It was interesting to look at a picture of Manhattan during the blackout. Some buildings were all lit up, many were dark. Those that were lit up had combined heat and power systems or other forms of distributed generation, which kept the buildings up and running. There was a number of public housing, universities, NYU, and a number of large office buildings as well. We learned a lot through Superstorm Sandy, and those best practices can really be used to improve the resilience of all of our buildings, no matter where they are. This is a quote from the Hurricane Sandy Rebuilding Strategy. This was published by the Housing and Urban Development Group. There were a number of different strategies. Recommendation number 14 was really focused on taking advantage of microgrids, smart grid technology, building controls, and distributed generation to provide two-way communication to the grid and provide greater resiliency. We think this is a trend. The things we do to make buildings more sustainable, passive design, use of renewable energy, also make those buildings more resilient. In our survey, 51% of the building owners had installed or planned to install distributed generation with a reliable fuel source to provide power for extended periods, and 39% installed or planned to install solar panels with a secure grid disconnect, allowing them to provide that emergency power. So clearly an emerging trend. When it comes to efficiency, our research suggests that lighting improvements, HVAC, and controls remain the #1 improvement. About 3/4 or 2/3 of organizations made improvements to their facilities last year in those particular areas. The emerging area, and an area which is getting much more attention, is energy-focused behavioral or educational programs. 44% had implemented programs within their organization to make those improvements. Looking more deeply at the research, specifically what they did is they utilized training programs, created dedicated energy champions or green teams within their facilities, developed online materials or used social media, up to and including installing kiosks and data displays to display the energy and resource information for their building tenants. That's a great way to get employees and customers and students and patients involved in actually reducing energy use. This is a picture of a new tool which was released through the Institute for Building Efficiency just this week, and a paper was presented at the BEC conference in California. The Sustainability and Engagement Navigator is a tool that allows organizations to screen about 50 methods and best practices around employee engagement to find the ones that best match the needs and the culture of their organization. And I would encourage you to review this tool. The second E in green is energy positive. We've been hearing for the past couple years about net zero energy, and really that's transitioning to energy positive. Buildings which not just use less energy and are as efficient as possible, but actually generate surplus energy that could be used to support their own selves, their communities, and the grid as a whole. The U.S. military, the Army in particular, has been very active in this area, and they have what's called a net zero initiative. Zero energy, zero waste, and zero water. And they've identified 8 installations around the world, most in the United States at this point, where they are piloting installations to be able to accomplish those goals. We're involved in 2 of those pilots. We're involved in Fort Bliss and Fort Carson, Colorado. This is a picture from Fort Bliss where we have installed solar cooling systems. So these are solar thermal concentrating collectors which provide heat energy to absorption chillers to provide cooling for a number of the buildings on the base. The U.S. Army is truly a technology and practice leader in this area, and I think is showing the way towards being able to deliver energy positive buildings, not just at an individual building where it may be very challenging to do it for all but the smallest of commercial buildings, but providing energy positive capabilities to campuses, communities, and other installations. 46% of the organizations we surveyed intend to achieve nearly zero, net zero, or positive energy in one or more of their facilities in the future. So something we'll be hearing a lot more about over the next decade for sure. And then finally, N stands for networked. There has been tremendous progress in the use of information technology to improve the design and operations and management of buildings over the past 2 decades. And one of the projects that we're very proud of is the retrofit of the Empire State Building, a project that was completed with partners Rocky Mountain Institute, Jones Lang LaSalle, and the Clinton Climate Initiative. This project is well known for a number of different reasons, including the remanufacturing of 6,514 windows on site. But what most people don't realize is that half of the 38% savings was actually due to the intelligent technology which went into the buildings. It was including direct digital controls on all the equipment. It was introducing tenant daylighting and automated plug load control. It was including tenant energy management portals for the individual tenants and demand controlled ventilation that responded to the actual ventilation needs of the building. Those 4 measures accounted for 20% of the overall energy savings. This is a picture of the tenant portal, the dashboard, which is a cloud-based application which all the major tenants in the Empire State Building will get, which allows them to track their energy use over time, comparing it week by week, month by month, and most importantly, allowing them to compare their performance with other similar tenants in the building. So you can imagine the likelihood of challenges and contests. Pizza party for whichever law firm actually makes the greatest improvement in energy use within their facility. Smart buildings rated the second most likely to increase in market adoption over the next decade. So, just in summary, we've done a very brief introduction to G.R.E.E.N. G.R.E.E.N is grid responsive, resilient, efficient, energy positive, and networked. The good news is that here at Greenbuild, there was the formal release of LEED version 4, the new version of the LEED rating system. LEED version 4 includes a number of elements which directly relate to these 5 key areas. It includes credit for demand response. It includes requirements for energy metering and monitoring. It includes retro-commissioning. It includes more rigorous evaluation and control of ventilation. Many of the trends we've talked about here are built into LEED version 4, and we think that it's great to see that there's not only innovation in technology and practices, but in the rating systems that we will use to measure the performance of our buildings in the future. Thank you very much, and for more information, I would refer you to our Institute for Building Efficiency. It's an initiative of Johnson Controls that provides industry information and research about smart buildings, sustainable buildings, and smart energy systems. Enjoy Greenbuild, and thank you very much for your attention.